Ladies and gentlemen, please welcome Senior Vice President, Security Products, VMware, Tom Korn.
Thank you. Thank you so much. Welcome. We have an incredibly exciting session for you today. As you heard for those of you who were present for Pat's keynote, we just gave birth to AppDefense, a system that we had been working on the technology really for the last couple of years. Incredibly excited for this. And in this session, we're going to set the stage for that. I'd like to share a little bit about sort of the vision and strategy overall relating to security in the software-defined data center and the cloud, and then dive specifically into AppDefense. But I think the real interesting part of this, and we're going to devote the majority of this session, is to really get in and take a look. And to do that later, we're going to actually set up a live application. This is a bit of a high-wire act. We're going to set up a live application. We're actually going to bring members of our red team up. We're going to do a variety of hacks, show you just how various types of hacking techniques work, even with security measures in place, and show you AppDefense in action. So as I said, it's your new application, something you work on for a long time. You think about it as your baby, and it made me think, leading in the weeks leading into VMworld, about my first child. Now, there's an old expression that your first child's made of glass, and your second child is made of wood, and your third child is made of solid concrete, right? And I remember that whole episode, for those of you who have kids, thinking about that experience of having your first child. It's quite something, from the planning phase to development to functional test and ultimately to general availability. But it wasn't until day 2 operations that it really was truly overwhelming. It didn't come with a run book, was no instruction guide or manual, and you're holding this fragile thing. This seems like the wind would break him. And you start to read about all these threats and articles on WebMD and Dr. Spock and on the web, and your mother-in-law sending you stuff, and you start to worry about, you start to think about, you start to picture all of these threats in your child, and suddenly that's turning into a steady escalation of calls to your pediatrician. Perhaps my son has Peruvian swine flu, I don't know. He seems to have certain symptoms. And then there's an intervention. And your doctor says, enough. Okay, you guys are cut off. You're no longer allowed to go to WebMD. You're no longer allowed to read Dr. Spock. This is craziness. It's not healthy for me, first of all, and certainly for you. And he gave 2 pieces of advice that sort of stuck with me. And the first was, look, here's the 2 things you can do. The first thing is set up a safe environment for your child, right? You should have access to what he needs in order, what he needs, but nothing more, right? You don't stick your child wherever you have space in the house. And this becomes, obviously, when they start to walk, it becomes more significant. But look, that's what they do in the hospital too. Consider the fact that where do we put babies when they're born? We put them in a nursery, and in a nursery, the policies about, first of all, who gets in and who gets out, and when a child is allowed to be taken out of the nursery is very clear. It's very focused. What looks weird in a nursery, it sticks out because we have a very focused purpose. I mean, imagine if we stuck kids wherever we had spare rooms in the hospital. It would be madness. I mean, thinking about who should have access to the child and not, and how do you, find something that might stick out as an anomaly. You simply wouldn't do that. Now, the other piece of advice that I remember is, know your child. Stop chasing threats. Know your child. Because some kids cry a lot and some kids don't, and some kids are hot and some kids are cold, and some kids eat a lot and some kids don't. It's when things change that you should call me. And it's this partnership between the doctor, who understands maladies and remedies, and the parent, who really knows their child. And it's, in essence, this collaboration between the two that really is what drives effective care for a child. And thinking about your critical applications as your babies, if you will. The last time you had your critical applications in a nursery was when you had monolithic stacks all sitting on a big hunk of iron. And that hasn't been true in a meaningful way in a very long time, because today an application has largely become a distributed system. It's a network of components interacting and communicating to each other. It's web servers and app servers and database servers. It's composed services with containers. And we have hundreds of these, thousands of these, all commingled on a common infrastructure. Right? It's a very, very different type of system. And in this system, the attack surface is simply too wide, and the complexity is simply too high. And this, of course, is taken advantage of in network exploitations. Think about the way we essentially have, in essence, distributed babies like we had in that other picture. Think about how we handle that from a security perspective. We try to compartmentalize our environment, but we don't do it based on what we're protecting. We do it based on the type of assets. So we might have a segment for web servers and app servers and database servers. But if one of those web servers falls, they all fall. And we've commingled components for many applications in any one of these segments. So not only can I move across applications, I can simply use the application itself to move across these boundaries, because the web server for an app has to be able to communicate with the app server for this app. And then on the compute side, we have a lot of intricate components inside those compute infrastructures, executables, processes, operating systems, interacting with each other. And of course, these are being manipulated with malware attacks and targeted attacks all the time. Two things we need to do, and it kind of goes back to that advice that I received from the doctor on that first child. One is that we have to shrink the attack surface. We have to focus on what we're protecting, the application, and we have to shrink the attack surface. And this concept of least privilege, sometimes it's referred to as zero trust, but this concept of least privilege, which was frankly, I think first coined by Professor Salzman at MIT many, many years ago, incredibly powerful concept, right? An application, a system should have access to the resources it needs to get its job done and nothing more. Fantastic way to shrink the attack surface, to improve signal to noise, to really get rid of non-value added risk. And the second is we need to start aligning our controls, not onto servers and networks, but aligning them to applications. Those are really the two pieces. This notion of creating least privilege and being able to enforce that by aligning controls to applications is really at the heart of what we're trying to accomplish in our security strategy and the things that we're building. Now, it's very interesting to me that when we talk about virtualization and more broadly cloud, we will often have conversations about the unique properties of clouds and how that might be used to do things very differently, to manage IT differently, to build applications differently, deploy and run and scale applications differently, except in security. And in security, what we often say is, well, how am I going to secure that? And while that's an important question, I think the more transformational question is, hey, is there a way to use those same unique properties to change how we do security? And there really is, right? This notion of taking what is effectively this overlay across our entire environment that sits between the infrastructure and the applications that we're protecting is a very powerful concept. So for example, on the network, the notion of doing least privilege on a network basis through this concept of microsegmentation, drawing a logical boundary around the components that make up an application or regulatory scope, and saying, these things need to talk to each other, but there's a limited set of things that need to communicate across that boundary is very, very effective. In that environment, one of those web servers falls, it can't just move easily laterally into that environment. And it also it exposes the logical boundary of an application. So we can start aligning security controls and security policies to an application, which is really what we're trying to protect. Similarly, obviously, to the talk this morning with Pat, we started to think a while ago about this notion of least privilege compute, right? This notion of thinking about what's actually running on top of this virtual infrastructure, and is it possible to create least privilege on that concept? Now, I guess to explain this, you need to think about what's inside those various machines. In those virtual machines, we have executables, processes, operating systems. Some of those processes are interacting and communicating with other processes on other machines in the environment, and that is effectively what an application is. And when a VM and an application is compromised, attackers are manipulating many of those components. They're modifying or manipulating the operating system, introducing new processes, modifying a process so it communicates to something different, like an attacker's command and control server, or to move laterally in the environment. And the majority of the security industry, and it's an important job, but the majority of the security industry is focused on how they can better and better identify threats, to be able to spot through various techniques, how do I find the threats and the attacks? But a model that is purely based on finding attacks will always be far more expensive and far less effective than one that can start by ensuring good. And that really is the idea behind this. Incredibly powerful concept. If you can understand what is the intended purpose and intended behavior of the system, to be able to ensure good can get rid of massive amounts of the attack surface. And it doesn't only help in reducing the attacks that might go on to that. What remains when it's used by analytics systems and other advanced systems is a much stronger signal to noise, a much brighter signal with much better context that we can do much better things with. So that is this concept behind AppDefense, this project that we embarked on really just a few years ago. And the concept behind it is really in three elements: capture, detect, and respond. Capture is about discovering and capturing the intended purpose and behavior of all of the VMs that compose applications, services, and regulatory scopes. Detect is about how we monitor what's running in the VM from a safe position, monitor what's running in the VM, and compare it to it so that if what's running doesn't match what was intended to run, then you go to response. And on the response side, to leverage the software-defined data center, to leverage the virtual infrastructure to be able to automate and orchestrate response. Now, to dive a little deeper on this than Pat had a chance to earlier, and what's really interesting about this is how it leverages the fundamental hypervisor and virtual infrastructure. Now, in capture, what we're sort of leveraging is the fact that from the position of the hypervisor, you have a unique view on what's running, but also what was provisioned in the first place. And we're leveraging that by not simply baselining what's running, but actually using more authoritative telemetry and intent of the application team. First, we hook into the vCenter in order to pull a full inventory and maintain a full proper inventory of all the VMs in the environment. But at that stage, we don't know the purpose or behavior. Next, we start to crawl through the infrastructure provisioning systems, Puppet, Chef, vRealize. That starts to shed light on, that machine, it's not just a VM, it's actually part of the database tier of this application. It's supposed to be running Windows 2012. It perhaps was supposed to have Python running on it. You can further get at application intent by looking at application automation frameworks, Ansible, Jenkins, Maven. These are the systems we're all collectively using to deploy the packages on those machines, and that sheds more light onto what was the processes, executables that we're expecting to see there, and how are they supposed to interact. Then we can trigger our position in the hypervisor to start monitoring what's really happening on that system in the production or in staging. And that starts to fill out a lot more things, because we might see things that from the operating system or from security products that you've deployed there. And so you end up with this set of behaviors and components that you see on that relating to an application that it's part of. And the system can then pre-verify and validate the pieces that make sense. Some things make sense because I've saw it in provisioning. Some things make sense because we can get reputational feeds on some of these components. Some of these, we understand the operating system components. Some of these make sense because we can see exact or very similar systems in your environment and other environments that inform us. What ends up is what we call an application scope, a birth certificate, a manifest for the application, if you will. And we maintain that as you update and patch the application, but it is based on authoritative telemetry that we use, and we break that into manifests for each of the VMs. We take those manifests and we place them into a protected zone. Now, to describe that, we're using another interesting property of virtualization, which is isolation. Now, this kind of goes back, many of you have heard some of the early code names on this project with Goldilocks, and it kind of goes to the concept of you can do security in two ways. You can have hardware on the wire or software on the guest. And they both have really cool benefits and downsides, and they're kind of opposite from each other. You do it as a box on the wire, you struggle with context. You have to reverse engineer a lot of context, but you have fantastic separation or isolation. If the guest is compromised, I can still function. On the guest, it's the opposite. I have fantastic context, but I'm actually sitting in the same trust domain as the attacker. So if the operating system and the other things fall, at some point the attacker goes to me. If the security technology is good enough to stop it, at some point the attacker goes and tries to turn it off, and that's a real problem. But in the hypervisor, we have the opportunity to sit outside, but we see privileged visibility into the guest. And so we've used some of these techniques to create a zone where we can monitor some of these components, and we store the manifests and a process, a monitoring process that monitors what's happening in the guest compared to the manifest. If it's different, we get a signal, and we understand what's different from what application, et cetera, and what process did that. And that leads to the third piece, which is response. And another interesting property of virtualization is it's entirely automatable infrastructure. From the network, the compute, the storage. And so we've used this to create a library of automated and orchestrated incident response routines, from snapshot to suspend to block, alert, quarantine, insert full packet capture. These library of incident response routines, which we're going to continue to grow. And so the policy for the system is very simple. If what's running doesn't match what was intended to run, what do you want to do? And we'll show you that in just a moment. So capture, detect, and respond, and it's used in the life cycle of the security process, from the security review and getting ready to put it into production and understand it, to detection and response in the SOC. And it is a collaboration between security teams and application teams. In fact, we've gone a step farther, and we've created a mobile companion app for AppDefense that could sit on the iPhones and Android phones of the application owners that will allow the SOC and the security team to interact and collaborate real time with the application teams. The security teams that really understand about threats and responses, and the application teams that really understand the application. It's very analogous to the doctor who understood remedies and maladies, and the parent who really understands their child. And that's what's incredibly powerful here, the ability to capture and embed knowledge of the application, and to use that to really transform security. I think security teams traditionally are most aligned with infrastructure teams, and this is starting to shift to enable security teams to partner more effectively with the application team. Now, as with anything we do, it's not just what we do, but it's also how we work and help with the security ecosystem. Now, everyone has a partner ecosystem, but I think what's powerful is if we can enable security partners to not just bolt on as they do in any environment, but architect in. And what that implies is that we actually expose the boundaries of the application and the context behind the application, that we can enable them to leverage the virtual infrastructure for response, that we can increase their visibility and even monitor some of their guest components. Then they can be inserted, aligned, they can get far greater visibility, and throughout this process to be able to feed those application context, to be able to help with response through automation, even to monitor their guest components. And the early spaces that we're partnering on are endpoint security, in security and information event management, and SOC analytics, and in security services. And so you'll be seeing some announcements coming from players like Carbon Black and Symantec and IBM Security and RSA and SecureWorks, a managed security service provider, and Optiv. And in fact, this morning, if you had an opportunity to go, it was a fantastic introduction with Mark Van Zalehoff, who runs IBM Security. And I encourage you, any of you, to go see their booth and start to see how this actually starts to look like in action, because it not only helps shrink the attack surface itself, but it actually can really change the kind of things that you can do with solutions like QRadar and Watson, et cetera. This is perhaps the essence of going beyond just securing virtualization to using virtualization to secure. And I'd like to stop talking about it and start showing it. And this is a high wire act because there are no smoke and mirrors here. We've actually set up a live application in our data center in Palo Alto, and we are going to hack into it. And we are going to, so this is, as I said, a high wire. To do that, I'm going to start by bringing on our application owner, Vijay Gante. Vijay, welcome.
Hey, Tom. Good to see you.
Thank you. So Vijay is actually only playing our application owner. In real life, he's an exotic dancer here in Vegas. Welcome, Vijay.
Hello. Well, what can I say? I make a good living doing that, so let's get started.
So Vijay, we have a multi-tiered application that focuses an EMR system, and I think you're showing it over here.
Right.
So yeah, please. Go ahead.
Yeah, so we're part of VMW Medical, and this is the patient portal. At the back end, it's essentially an EMR application, as you mentioned. What I'll do is I'll just log in as you, and as usual, I have all your credentials. So
it's on a Post-it note.
So this application has a lot of sensitive data, right? So if you were to look at the lab results, it has all your medical data. Clearly, you're due for another annual checkup, that's right. And if you look at the profile, it shows your insurance ID, your social security number, so very important data. And it seems like you delivered AppDefense today.
I know, healthy.
Congratulations.
Healthy 2 million lines of code.
Right, and so that's the application we're going to hack today.
All right, so terrific. And this the construction of the application. In fact, I think if we can bring up the screen and the slides just to show people. Okay, terrific. Oh, is this on your?
Yeah, it's on mine.
Okay, we can flip over onto Vijay's screen and you can take a look at it there. Okay.
Yeah, so this is a standard 3-tier application.
Yep.
The 3 tiers being the web tier, the app tier, and the database tier. Web tier is running an Nginx server. Right?
Yep.
It's listening on SSL port 443. The app tier, it's a Python application, and it has Django, which is the web application framework for Python. And on the back end with the database tier is a Windows SQL Server. Okay. And the interactions between these components essentially are the app tier is talking to database tier using the standard 1433, 1434 port.
Okay, so you construct the application, and then to put that application on the virtual infrastructure, you would use some provisioning configuration system. So kind of walk us through what you're doing there.
Exactly. So like most IT automation teams, we want to make our lives easy.
Yep.
In our case, we use Puppet. We have to specify as part of automating this, all the composition information and the component interaction information.
Right.
Let me very quickly show you the manifest files where this is captured. So what you see here is the application composition. It says it's an EMR application,
okay, and
shows you the DB tier, the app tier, and the web tier.
Yeah.
Also points out the component interactions that are specified, right? Let me dig deeper a little bit and show you one of the service tiers. And this is the manifest file for this particular service tier.
Yep.
And here it shows the composition information that you talked about. It's a Python and Django packages are deployed on this.
All right, so this isn't just for next-gen apps. More and more organizations, even for legacy systems, are using provisioning and automation systems. It improves efficiency. It helps ensure fewer user errors, et cetera, right?
Absolutely. Okay. We capture a whole lot of application information.
All right, so this is done. Can you roll the application out?
Oh, I wish it was that easy. I've got Chris, the head of InfoSec. It's on my back all the time.
Evil guy.
So yeah, I mean, there's sensitive data that we need to go through an elaborate security review process before we can put it in production.
All right, so with that, why don't we bring up our InfoSec person, Chris Cord. Chris, welcome. Hey. So in full disclosure, Chris is only playing our InfoSec person today. In real life, he's a bookie here in Vegas. So
yeah, McGregor was my retirement plan.
Yes.
Unfortunately, that didn't work out.
All right. So good. So let's take a look. We just heard from Vijay that he's ready, but you need to and walk us through what happens now. What's the security review process?
Yeah. So I can't. This application has a lot of sensitive information, right? So I can't just let them go out and deploy it without giving security a good idea of actually what we're looking for. So typically, what we'll have the application owners do is go through a fairly lengthy review process, right, with the security team, mostly to have them give us information about what the application composition is, what kind of behavior we should expect to see at runtime, all things that when it starts to get dropped in our lap from a security operations perspective, we can be expected to be able to triage events and things that we see after we get them.
Got it. Right. All right. So what was that? Is it a couple days? What is that?
No, I think he wishes that it was a couple days, but I think it's usually a month, if not multi-month process. I mean, by the time we get all the information over, plus we have to go through a change review process so that we have to make sure that if he's making changes to the application, that's not something that's going to flag as false positives on our end.
And walk us through, I mean, so you can go through that process, you start to amass that. At the end of the day, what kind of controls do you put in place, and how much can you customize it for his app?
Yeah, I mean, so most of the controls, like from an actual protection perspective, are standard, right? So we use standard AV on our servers and other things like that on the environment. Most of the application composition and security review process is mostly to help our SIM process, right? So our ability to look at events that are coming in through our SIM. So we put log aggregators, log collectors, right? And we try to collect all the information on the back end, and then when we get events, we try to triage those events based on what we know about the app, right? But we usually are a little bit behind in terms of any changes that he might make from an application perspective.
All right, so perfect. We have set up this application. It is running live in our data center in Palo Alto as we speak. We are connected to it remotely from here. We have set it up with security components. It has endpoint security elements on it. It has some network security components. And now we're going to hack into it. And to do that, I am going to bring up our hacker for today, Prajwal. Prajwal, welcome. So Prajwal is actually a member of our red team here who works in our CISO's organization. Prajwal actually does hack for a living, but he's a white hat. He actually does a lot of pen testing for us. And Prajwal, we are going to, and actually if you could switch onto my slides for just a second, just to kind of give some orientation for what we're about to do. We can switch that to screens from the monitor. So we're going to do a three-stage attack, sort of three different attacks to kind of show a variety of techniques. The first attack we're going to do is exploitation. This is our kill chain here. The exploitation piece, as you'll see, Prajwal is going to use some techniques using Python to break in. Secondly, he's going to do a second hack, which is once we're on that machine, extraction. How do we connect and extract the data out to that? And then the third piece is exfiltration. Prajwal is going to do a third attack, which is kind of test some techniques for sort of moving that out. So, Prajwal, let's start in the beginning. We'll switch on to Prajwal's screen if we could. Let's take it away. How do we start?
Okay, so I look through the application to find vulnerabilities so I can exploit and get into the application server. Doing that, I found a vulnerability in the zip code field, which allows me to do a command injection attack and get shell access to the application server.
Okay.
So for doing that, I wrote a simple Python script which will connect back to my machine and gives me the command prompt of the machine. So I got a base64 encoded Python script, which I'll be using and pasting it in the field here. And when I click on search, the script will get executed, and you can see that it opened up a session on my machine here.
Okay, so as Prajwal is doing that and setting up his persistent connection, just to orient you, injection attacks are relatively common. A lot of the vulnerabilities we found, some of them were just kicking around from Prajwal, but there's also sites that are showing vulnerabilities of Django components, et cetera, and various web components. So in the injection attack, injecting some Python code into that field is allowing Prajwal to set up a remote TCP connection to a Metasploit server that a machine that he has on the outside running Metasploit, which is often used by red teams. And he's going to be using that to connect. So now you're essentially on that machine as like an administrator.
Yes, so when I drop to shell, you can see it's a Windows machine that's running it.
Yep.
And when I click on type in who am I, you can see that I'm an administrator on the application server now. So I tried looking to the various settings, and since it's running a Django application, the settings file is the most crucial file, which has all the critical information like the connection settings, the authentication settings, and other kind of such information which are really important for the application setup.
Yeah, so the system has to have some configuration and settings that instruct it where it's going to connect to for the database and how to connect into that database. So let's take a look, and you'll get that kind of information out of it. By the way, you're incredibly well dressed today. Where'd the hoodie and the earring and the tats go?
Oh.
All right, so here we actually see the various pieces on that. So you have armed with that information.
Yes.
As I understand, as we move to the extraction phase, what Prajwal is going to use that information and to mix things up, he's essentially created a PowerShell script.
Yes.
To be able to take those components and to do some extraction. So
yes, so we'll use the information we got for the login into the database in our previous step, and I will be uploading a PowerShell script which will be used, which will use these credentials that we got in our previous step and extract the database. So I uploaded the PowerShell script here, and I'll upload one more script which will do the next step of exfiltration as well. So,
okay, so you're uploading that script onto from your machine onto that server.
Yes.
And then you'll execute that.
Yes. So the first step, I'll execute the PowerShell script, which will dump the database.
All right, so again, at this stage, the extraction stage, he's created a small PowerShell script. It's using the settings and credential information we found in the settings file on that app server. That is reaching out to the database server in order to extract the information and pull it onto the server that he's sitting on.
Yeah, so it downloaded 854 records, as you can see.
Okay, so let's take a look. So you just dumped it into a CVS file, and there you have.
File, yes.
Yeah. Great. All right, so there you have it, and you have even my record over there.
Yeah.
Okay, terrific. All right, so now we have the data, and now you want to get to exfiltration.
Yes.
And for that, I think you're mixing it up again, and you're using another Python script on it.
Yes. The database on the application server doesn't, it's not really useful for the attacker because it's still on the application server within the infrastructure itself. So the next step, obviously, to exfiltrate it to the public cloud or somewhere where I can use it later on.
Yep.
So it's uploading to a.
There you go. All right. So, gentlemen, you spent a couple months securing that application, and Prajwal took it apart in just a couple minutes.
Yeah, I knew there was a reason I didn't like that guy.
Yeah. All right. So let's see the kinds of things that happen. How do the properties change when you can set up a least privilege environment and when you can actually lock this down, and what AppDefense actually does? And to do that, we have Chris's screen. So Chris, this is AppDefense, right? You're looking at the main dashboard screen. Walk us through what you're looking at.
Yeah, so one of the reasons why the attack that you just saw was very difficult to stop against is Prajwal used actual connections that were necessary to be there in order for the app to function, right? So we took advantage of the fact that the web server had to be facing the internet, took advantage of the fact that the app server had to talk to the database, so we need to have a firewall port open between the app server and the database, and he used all of those legitimate channels essentially to perform his attack, right? Yep. So what we want to be able to do is layer in AppDefense on top of this and actually get a more deeper granular view of the application behavior and kind of pick out those anomalies that we're seeing in the activity that Prajwal is performing in order to stop this attack.
Great.
So the first thing that we need to do is actually orient ourselves and get an understanding of exactly what the virtual machine behavior is, right? We need to go through that process of creating the manifest that you described earlier. So what we're looking at here on the dashboard is just essentially your status on how much we've gone through the creation phase for your virtual machines. So in this case, we have 34 virtual machines that we've synced from vCenter. 30 of those we really have no information about. So that is what we call unassigned virtual machines. It essentially means that they're running, they're doing their thing, we just don't know what they're doing or why they're doing it. From a security perspective, we're unaware of those. 4 of those we actually have running in sort of the mid-ground here, which is discovery state. And this is a period where we have some information about the application, its composition, but we're actually still going through the period of learning to get a full understanding about what it is, right? So we'll talk about the application that we have in discovery state in a second. And then obviously we want to be able to move as much as we can over into green. There's nothing in green right now, but green would be fully protected by AppDefense, right? So ideally you'd have 100% of your VMs in your data center running on green.
All right, so the main concept is you turn it on, in the beginning everything's red. I have no idea what the purpose of these machines, and as the system is going to start chugging through that, you're going to see machines pop out of red into orange as they start to figure out, I know what the purpose is, and they refine that model. When Chris wants to lock an application down, he's going to turn that and it'll turn into green.
Right. So what we want to be able to do is start that process, right? And we could go through a manual process of actually looking at each virtual machine, going back to VJ, asking him to feed me information about the intended purpose of that virtual machine, but that would be tedious and manual, and it's going to not really help from the same perspective that we have today. So what we want to be able to do is actually tap into that automation flow that you talked about before, right? So this is like any modern data center has the automation that VJ has in place in order to run his applications and his environment. Yep. And in this case, Puppet has an awful lot of rich information for us to be able to pull from. So we're going to go in and just enable the AppDefense integration with Puppet. And as soon as we do that, right, AppDefense will start going in and crawling through those Puppet manifests and Puppet Orchestrator, the things that VJ showed before, and start extracting away application composition, understand what VMs are assigned to particular applications in actual production live instances, and then start populating some of the behavior based on the Puppet manifests that have been described already by VJ.
Yeah, and I think one of the things that's exciting is you already actually have in various systems a lot of rich information captured from the application team. You're just not mining it yet for security purposes, and that's what we're starting to do here.
So what we have here now is a new scope, right? And this is essentially the EMR application day zero scope, right? So this is all the information that BJ had running in his Puppet instances. Yep. We just now pulled over and created a new day zero scope. So this, no information had to be manually fed to us. This all came from the configuration.
And a scope being an application or a regulatory scope or some sort of composed service.
Exactly. A scope is the highest order grouping within AppDefense, right? That represents the app. So now that we have this view of the application, we actually have a pretty decent amount of data about the way the app should behave, purely from getting information from Puppet, right? And really what we see here is we understand the higher order scope, the EMR app. We understand the fact that it's a 3-tier application. We understand explicitly what those application tiers are encompassed of, right? So we know that this is a Python server and running Django. We know that our database tier is running SQL Server, right? All of this came from the Puppet manifest files, right? Because Puppet is describing the specific packages that need to be installed in those machines, right? So we're pulling from that information and getting all of that data. The other thing that we can get is application composition, right? So Puppet Orchestrator, which VJ is making heavy use of, talked about, you know, the components of the app and their communication paths, right? So in this case, we can see that we're running the app tier. We expect to communicate to the database over port 1433 and 1434. We expect to communicate to the web tier. Again, all fed from Puppet Orchestrator. And then the packages that were installed in Puppet are the Python packages, right? And these are the particular hashes that describe the Python process, right? So again, this is completely day zero. Nothing had to be learned at runtime. This is all information that we're able to feed in just from tapping into Puppet.
So that's the power of mining things like Puppet and Chef and vRealize and some of the application automation frameworks that get more into the packages that are being installed there, like Ansible, Jenkins, Maven.
That's right. So that's the starting of the process, right? So there are going to be things that we cannot get fully from the provisioning system, right? So in order to show that, we've done the cooking show trick here, right? So we have a other scope that's been running for 10 days, and that essentially has gone through the additional periods of learning or additional inputs of learning that you described during the creation phase, right? So this is where we start to evaluate things at runtime and start matching them back to understanding of application templates that we're aware of, understanding of commonality that we are aware of, and then understanding of reputation feeds that we pull in from external vendors.
Got it. So this is after a 10-day learning period.
Exactly. So now we're in the learning period, and we now have a deeper set of behavior, right? And the reason why we have a deeper set of behavior is these are full-fledged operating systems. These are, you know, Windows-based operating systems. Windows generates a decent amount of noise, right? On the back end, Linux would be a little bit cleaner. So it augments the things that VJ has from an application composition perspective with all the things that Windows is running behind the scenes, right? There could be update processes. There could be other things running behind the scenes for Windows. The interesting thing here is, though, we have 91 behaviors. 90 of those we've been able to pre-verify, right? Because we've gone through this machine learning process, right? We've consolidated all these inputs, and essentially now we've been able to pre-approve these behaviors on your behalf, right? So we have a full and complete composition of the app, very granular down to the behavior level, but we were able to pre-approve an awful lot of those.
So a mix of feeds from the provisioning systems as well as being able to look at reputational feeds from like companies like Carbon Black to be able to do some process analysis stuff that some of the countercheck team, the things like looking across the environment to see other similar type of systems, all of that helps us to craft this and pre-verify and pre-validate a lot of these.
Exactly. And even we further take the things that we see at runtime. So if you tap into Python here, this is specifically the entry for Python in the manifest, right? So it says that Python's allowed to run, this hash is allowed to run. It's also communicating to the database tier on port 1433 and 1434. And remember, this is a viewpoint of expected behavior, the things that we want to be able to see and want to be able to allow. In this case, we can say, look, Puppet told us that you're going to be talking over these ports, right? And we saw the actual communication over these ports, and we validated it against the actual composed packages that Puppet put down there, right? So we've kind of further validated via these inputs the things that we're seeing.
All right, but you do end up with some things that don't necessarily clear out from that. So walk us through how you verify.
Exactly, right? So in this case, I see one behavior, right? This is looks like a custom component, the EMR tracking component, right? That someone on Vijay's team forgot to put into the orchestration system. How dare he? So like this is, sometimes happens, right? The people don't necessarily feed things in via the appropriate channels.
Yep.
So we see this behavior. We weren't able to verify it. We haven't seen it on any other machines. It wasn't in a reputation database anywhere. So I need to kick this back to Vijay for validation, right? So the interesting thing here is we have the ability to send this directly over to him via the mobile companion app that you talked about earlier. So we're just going to click send to owner, and this is going to share this, this behavior over to Vijay for him to validate it.
All right, so Vijay, you have your mobile phone here. It's running the AppDefense app on the mobile phone. So kind of walk us through what you see. And folks can see this now up on the main screen.
Fantastic. Yeah, so as I know my application is going through a review process, I'm expecting some things to be verified by me. I tap on this. I look at this, and this is a custom component that we have developed.
Yep.
I look at the specific behavior. It's communicating on port 3128, which is, again, as expected. This looks fine to me, so I'm going to tell Chris that this is expected and write him a nice note, because it's being nice to me now. And I just send it, and we're done. That's all.
Terrific. All right, so Chris, how does that then show up in the AppDefense and the security console?
Yeah, so you can see here we have a little notification icon here on this behavior, right? And I can look at this and I can see the very nice note that Vijay was able to write.
That is like the fastest typing ever.
Yeah, he cut and pastes very well on his phone. So we now see that, look, the application owner says everything's good here, and we can just verify it, right? And once we do that, we now have sort of essentially, we've taken all of that manual review process that we typically would have to do, and in fact, augmented that manual review process with a lot more detail than you could ever get.
Yep.
And we essentially made it a very quick and easy and painless process for the app owners, right? And not only do we get this view of a fully validated state, but if he makes any changes, which he should do through the appropriate channels in Puppet, we'll actually pick those up and make those adjustments inside the application in real time.
And if he doesn't, if he goes manually and makes changes, you'll also pick that up, and then you can have an interaction.
Exactly.
Okay.
We'll be able to send it back.
All right, so how do we then put this into protection mode?
All right, so now that we have this fully validated and verified scope, there's no behaviors here that we need to be concerned about. We can simply kind of move this over into protected mode, right? And what that does is essentially takes it from the orange bucket that we talked about earlier and moves it into the green bucket, right? And it essentially means that we're now going to be start to use the hypervisor and start enforcing and watching for behavior at runtime and detecting if there's any anomalies in behavior that we see versus what the application composition is telling us should be.
All right, so let's take a look at what those policies look like.
So the rule sets are actually fairly simple here, and they're simple by design, right? Because as soon as we move it into protected mode, we enable all the rules by default. Super easy to turn them on, turn them off. You just have to turn a slider here. And the reason why they're simple is the fact that we've done all the hard work, right, in the creation phase of building out that manifest, right? So you don't have to create a very complex rule set when you want to start enforcing things. You simply just need to tell us that you want to start a particular piece of enforcement. So in this case, for outbound connections, I'm actually going to adjust the remediation action.
Okay.
And the remediation action is explicitly the kind of last leg in the AppDefense picture, which is what should we do when we see a violation, right? And you can block the behavior immediately if you want to have a more traditional app control use case, or you can go through the ESX and NSX remediation brokers and take more advanced actions.
Right.
In this case, I'm going to block and send an alert. And for the app module integrity, which I'll explain more in a second, I'm actually going to suspend the machine because this is a serious violation, and I want to make sure that no one can actually implement something like this. One other interesting thing is these steps can be taken manually or automatically, and if by manual, it means that we'll actually send the alert to the AppDefense console, through the SIM systems like QRadar, and you'll actually have the ability for the SOC analyst to say, what's the recommended remediation on this? After they've seen it, issue the manual action. In this case, I'm just going to keep it automatic, right, for the sake of the demo.
All right, so the key here is that policies are not like a firewall policy. You're not trying to craft all things. All of that has actually been done. The intelligence behind it is doing that. The policy is simply, what do you want to do if what's running doesn't match what was intended? And you can, as Chris said, you can kind of break this down by behavior type. Is it a process communicating out, or listening, or an operating system piece?
So basically the 4 rule types, right, are outbound connections and inbound connections, right? And essentially what that means is the process hash, the CLI arguments will all match the outbound behavior definition that we have in the manifest. So the port that you're using, the protocol that you're using, the destination address that you're using, right? Yeah. So those things have to match in order for this to be able to be an allowed behavior. Same with inbound connections, right? If you're listening on a port, we want to make sure that's the right processes listening on ports. The other interesting thing that we do is enforce operating system integrity. So in this case, the hypervisor is actually looking at all of the operating system kernel code to ensure that no one manipulates or changes the kernel code in memory, right? As soon as we see anyone tamper with that, we get an immediate notification if this rule is on.
Got it.
The other thing is the AppDefense module integrity. If anyone tries to manipulate, turn off, change anything that we have from an AppDefense protection perspective, again, the hypervisor gets immediate notification, and we get immediate ability to trigger this rule and sort of take action.
So the significance of that kind of goes back to what I'm saying earlier, which is the challenge in a lot of endpoint security is you're sitting in the same trust domain, and if an attacker is getting stopped multiple times, at some point they say, something's stopping me, I'm going to go try to disable or manipulate that. So this is starting to say, actually, not only can see that, that's a wonderful signal, and we can react to that here. And we'll be enriching some of these pieces, but as Chris said, by design, we're trying to keep this incredibly simple. All right.
So I'm good.
Terrific. All right, so we have that in place. Prajwal, the gauntlet has been thrown. Let's run through your attack. Let's start with the exploitation to begin with. So this is your going into the website, doing an injection attack.
Yes. So like in previous stage, I bypassed the endpoint protection, got administrative access. So I hope there's not much change in the attack, and it should work even now with all the protection you have. So I injected it and clicked on search, so expecting a connection soon.
It's not working for you, man.
Yeah, looks like it.
Why wouldn't an attack like this work? Because suddenly there is a process on that machine doing a communication pattern on the machine that isn't what VJ designed. It isn't in its intended purpose. And as a result, is the default things that the hypervisor is now kind of watching over that and saying, hey, I understand good. If it's not good, it's bad, and this is what's happening on that machine. All right, so let's assume you manage to get onto that machine,
yes,
right? And you find another way to get on that machine. Let's go to the second stage of the attack with extraction and try running that.
Okay, so let's assume I got the administrative credentials in my previous attack. So I use them to log into that machine, and we'll try to use the same PowerShell script that we used in our previous step. And it's executing now.
It's not working for you, man. All right, why wouldn't this work? It's the same explanation. He's trying to run some process or modify a process, and he's doing a legitimate connection. The app server and the database server have to connect to each other. But the connection and the process behavior is different. It's not what VJ didn't design this process communicating to that thing. And if it's not good, it's bad. And that's what AppDefense went and stopped. All right, let's assume we figured out a way to do that and try exfiltrating it and try using your Python. Now, the interesting thing about this, and while Prajwal is doing it, please proceed, Prajwal. The interesting thing here is that, he's doing that as a Python server. We're actually running Python for the application. His exploit here is a Python exploit. So it's not like saying he's trying to block Python. But the nature of that process and the communications that it's doing doesn't match what VJ built. It doesn't match that application.
Well, since I don't have any data down, it doesn't make sense for me to exfiltrate the data from there.
Yes. That's true. All right.
We hit a roadblock there.
So what are you going to try to do next then?
So the obvious answer would be for me to try to find the process that's blocking me from making these connections. So I would need some time to figure out how to do that.
So hold that right before we go that. So you're bringing up a good point, so Chris. So let's see what was happening on your console on while that was happening. And hold that thought, Prajwal. So what was happening on your console?
Yeah, so essentially, you saw that we were able to successfully block the attacks, right? But obviously, we want to be able to get visibility into things that are happening and why they were happening in the first place, right? So what we see are AppDefense alerts, right? Alerts that are being fed to the console. These are also alerts that are fed to your SIM system, right? So a traditional SOC would typically get these as a first order event in their SIM. And we have two behaviors here that we were, took a block action on. So if you take a look at the first one, in this case, this is the initial command injection that Prajwal tried to run, right? So this is when he first tried to connect into the machine via command injection. So the interesting thing here is it's using Python, and if you remember, Python isn't allowed executable on the machine, right? So if you're using standard just process-based whitelisting, right, this wouldn't have been able to stop this, right? But the fact that the process was actually communicating in a different way, and it was actually being used in a different way and communicating back to his command and control server, that's the anomaly that essentially was seen and stopped, right, in this case, right? So, so that's sort of the initial stop. And then when you look at the second one, this is actually the second phase, which was where he was going through the extraction phase of the attack. The interesting thing about this one is the fact that the destination IP and the destination port, which is the database IP, and the port that we said was open, if you remember back from the beginning, 1434 was open, those are perfectly allowed, right? That's a perfectly allowed firewall legitimate connection between the web server, the app server and the database. But he used a different command line process, right? Or a different process when he tried to execute this, right? So that's the way we flagged this one, is the fact that even though you're using a legitimate path, it's still a different process using that path, right?
Got it.
And we're worth noting that even if he used Python here, the CLI arguments would have been different for him to run a Python script versus the application itself. We still would have blocked it, right? Because we look at all of these behaviors. So in this case, right, we have these violations. We've seen them. Now, VJ likes to go rogue sometimes. His team likes to go rogue sometimes and run PowerShell scripts and do crazy stuff, right? And I always tell him not to do that, but he does it. So I'm going to go in and actually send this behavior over to VJ via the same channel that we had before to just see if this was something that he was doing, right? If this was a false positive that I should be aware of. So exact same channel, we're going to hit the mobile app and essentially get some input from him.
All right, so VJ, let's take a look now. Again, we'll switch screens onto you so we can all see your mobile app. And what did you get here?
Yeah, now that he's got my back, he get to call me names. That's good. So I have this alert. I'm going to tap into this. Look at this. This is a PowerShell script, but the script doesn't look like something that my team has written. So I'm going to just say this is not expected. I'm actually now worried. So I'm going to type in another nice message for Chris and send it back to him.
Fast typer, my friend. Okay, so Chris, let's take a look. How does that show up on your console then?
Yeah, so in this case, inside the alert window, we got our comments back from VJ. He seems worried, right? Now I'm worried, right? Because now I'm thinking we have an attacker in our midst and things are problematic, right?
Got it. All right. So at this stage, Prajwal's getting frustrated, and something is stopping him. And the logical thing to do in this attack sequence is to try messing with that process and turn it off.
Yes. So I look through all the processes on this system and try to identify what is blocking my attempts to connect. Because, like I said in previous case, the system has all the endpoint security, but I was able to bypass them.
Right.
So there's something more at picture here that's acting and trying to stop me from making the connections.
Yes.
So I identified the processes that are running and blocking me from making the connection. So I wrote a simple script that will inject into the process and try to bypass it so I can go on with my attack and exploitation. So I'm going to run that now. Just throwing some random.
We're heading into the matrix.
Okay, so looks like it successfully ran. So I think I should be able to do all the attacks now that I was doing. Okay.
What's going on?
Something's wrong with my keyboard.
Your computer froze?
Looks like I lost the connection to the system.
You have been completely shut down, my friend. So what happened there, Chris?
Yeah, so if you come back to the AppDefense screen, right? So if you remember earlier, we actually set up a rule for any AppDefense module tampering. If someone tried to manipulate or tamper that, we get immediate notification of that and take an action. And this is the action that we specified in our policy was to suspend, and to suspend automatically, right? So what you saw there is essentially the alert that we see right here, which is the fact that we got AppDefense module tampering, right? The hypervisor immediately sees that, and we took the suspend action on your behalf. Yep. And you could dig into the details here and see that it was something called girogue.sys that was doing the manipulation. But yeah, in essence, we've already sort of taken an automated response action and sort of self-healing action and taken our attacker completely offline.
Got it. All right. Well, terrific. That is extremely helpful. Thank you, guys. If we could actually switch on to the other screens, onto my presentation. So we've sort of seen an idea of this exploitation, extraction, and exfiltration. But I want to leave you with two numbers, 91 and 27 million. We were protecting that application server by understanding 91 intended behaviors, not by trying to chase 27 million different strains of malware that change every single day. And that is the incredibly powerful concept behind not simply chasing bad, but ensuring good. You can sort of think of AppDefense as the good guys. Now, we'd love to share more with you. I know there's only limited time in this session, but we have created a variety of things for everyone to be able to dive deeper, and we hope you will. I mean, I think this is perhaps one of the most powerful advancements in security I've had an opportunity to work on. I think it could make a huge difference, and in its simplicity, I'm hoping that people will really leverage this in as many places as possible, because it simply makes sense to be able to allow the things that should happen and anything else should be bad. So we have a series of sessions. There's one later today that VJ is actually running, and that is actually going to include members of our own SOC team and security architecture team. We have a session tomorrow that Chris Cord is running that we actually have some customers who are actually with us also adding more input on it. On Thursday, Dennis Moreau is having a session that goes a little deeper onto architectural and sort of longer range concepts on it. We have a pod in the booth where you can play with it. We also have a hands-on lab that you can use it and you can play with it. After the show, or for the people who haven't had a chance to come, we've started to populate the website with a bunch of materials, from videos to white papers. Recordings of this session will go live on that. And of course, anytime, please feel free to reach out to us at VMware, and we'd be happy to have a conversation. We really think we can elevate the level of security with AppDefense and with this approach. So enjoy the rest of the show. Thank you so much for coming.